Okay, class, here comes one of the hardest subjects, I think, in this chapter, and this is blood pressure control. I want you to read the textbook thoroughly as far as when it comes to blood pressure regulation. I think the book is excellent in that, particularly the one we're using, but the other books, that if you don't have this one, is okay also. All right, I have 2 PowerPoints now on blood pressure control. I have this PowerPoint here, which is called blood pressure control, that you'll find in ENP2. Then I've made another one, which I'm going to call blood pressure control simplified version. So I'm going to use both, and I suggest you look at both, but again, the textbook is good. So we're going to try this and kind of see. This is one of these kind of things a movie actually does better, but we're going to go. All right. When it comes to blood pressure control, I'm going to say it this way. We have widespread control, which would be all over the body, and then we have local control in certain organs. Let me explain that. Okay. Let's use it in this analogy. We have a power company in Houston called CenterPoint, and they control the power pretty much all over the city. Hospitals, however, have a backup generator. So CenterPoint would control the overall light power all over. But if CenterPoint had trouble and hospitals cannot afford for the power to go out, they have a backup generator that would control them. So what's my point? We have widespread control, but certain organs cannot afford to lose blood pressure. So they have a backup local control mechanism. We'll kind of talk about that here, and we'll also discuss that when we discuss shock. Okay. So widespread control and local control. Widespread control is all over the body. The 2 systems that can go all over the body and send a message is the nervous system and the endocrine system. The nervous system and the endocrine system. So as we discuss widespread control, I'm going to talk about the nervous system and the endocrine system. All right. As you think about blood pressure control, go back to your MAP formula, this one here. This MAP formula explains everything. It looks at cardiac output, the heart rate, the stroke volume, inotropic and everything, blood vessels, which are a resistance. So this explains everything. So anything that would affect blood pressure would either be dealing with the heart rate, the stroke volume, volumes, vasodilation, vasoconstriction. That's all we got. But there are many things that can impact on this. All right, so this is kind of the overriding formula to keep in the back of your mind. All right, when it comes to nervous control of blood pressure, we have the cardiovascular center. We earlier in the heart talked about the cardiac center. And the cardiac center had the cardiac acceleratory center and cardiac inhibitory. The cardiac acceleratory center, go back, could increase blood pressure because the cardiac acceleratory center worked via the sympathetic nervous system. Therefore, it could impact heart rate and stroke volume. Norepinephrine could make you squeeze down harder, inotropic. Okay. Now we're introducing the vasomotor center, which is part of the cardiovascular center. And the vasomotor center has a vasoconstrictor center and a vasodilator center. Okay. Now, with the cardiac center, you had the cardiac acceleratory center working via the sympathetic and the cardiac inhibitory working via the parasympathetic. With the vasomotor center, the vasoconstrictor center works via the sympathetic. The vasodilator center does not have an output. What it does is send signals to the vasoconstrictor center. So the vasodilator center could send a signal to the vasoconstrictor center to tell it to turn down some. If it turns down, then there will be more vasodilation. So again, the vasoconstrictor center works via the sympathetic nervous system. The vasodilator center works just to ride herd or control over the vasoconstrictor. So it has no direct output. Here's an example of our cardiovascular center. So we have a vasomotor center and we have a cardioregulatory center, which is called the cardiac center, just to show you. Okay. Here is a picture, shall we say, of the vasomotor center. And we would have a vasoconstrictor center and a vasodilator center. Vasodilator and vasoconstrictor. Right here's another picture. Vasomotor, I said up here would be vasoconstrictor. Down here would be vasodilator. But the vasodilator rides herd over the vasoconstrictor. Now the vasoconstrictor center uses the sympathetic nervous system. Okay? When it does that and goes to the blood vessels, this is how it would go to the blood vessels, those nerves. Now, remember we talked about this with norepinephrine, epinephrine. With the heart, it was beta 1. Norepinephrine and epinephrine work on alpha and beta receptors. Alpha receptors are on blood vessels. Okay? That's what's on blood vessels. All right. So, we go further. With the cardiac center, remember that we had certain inputs from the cardiac center, the sensory. We had the aortic pressure receptors, and we had the carotid pressure receptors. Here they were, the baroreceptors. We sent some fibers when we did the heart into the cardiac center. Now I want you to think that we're going to send some of the same fibers into the vasomotor center. Okay. So the way this would essentially work is this. If the blood pressure was too high because there was stretch on the carotids or the aorta, then remember when it sent signals to the cardiac center, it would turn down the cardiac acceleratory center if the pressure was too high, too much stretch, and turn on the cardiac inhibitory, which worked via acetylcholine, the parasympathetic. Now, let's think on the vasomotor. If there's too much stretch, which means too high blood pressure, then the signal would go into the vasoconstricting dilator. The dilator then would send a signal to the vasoconstrictor center to say back off some. Because if it backed off some, there would be more vasodilation, the radius would get bigger, and resistance would go down. If R goes down, then SVR goes down. If SVR goes down, then what will happen is, if SVR goes down, blood pressure will go down. So in other words, what you want to do is vasodilate the blood vessels, which would then assist in bringing the pressure down. That's how that vasomotor center would work. I want you to read on it though. Okay? I want you to read on it. All right. Now, over here, I want to bring something up to you over here. I want you to become familiar with the reticular system. The reticular system is in the brain. It's a diffuse set of neurons in the brain that keep us alert. The firing frequency of the reticular system determines the states of consciousness. The firing frequency of the reticular system determines the states of consciousness. So the faster the firing frequency, the more alert. But the reticular activating system also keeps the other centers awake. That means the cardiac center and vasomotor center. Now, if the RAF goes out, reticular activating formation, then the heart will keep beating because the heart had autorhythmicity. The blood vessels will still work. You may get a little more vasodilation because you've knocked out the vasomotor center. But in a moment, you'll see the blood vessels won't go completely vasodilated because you still have the endocrine system we're going to talk about. The only system that's going to have a problem is the breathing system, which we'll talk about in another chapter. It has no backup. So the reticular activating system, the firing frequency of the reticular activating system determines your states of consciousness. The firing frequency of the reticular activating system determines your states of consciousness. The faster the firing, the more alert you are. When you're brain dead, that means you have no background firing frequency from the reticular activating system. Okay? So that's what we're looking at there. All right. So now we go a little further, and we're going to talk about hormonal control of blood pressure. So we're going to do another video starting with hormonal. This was the one on the nervous control of blood pressure.